Hello friends, welcome to Electrical Circuits. In this video, we will focus on Norton's theorem. We will learn the process how to reduce circuit and also practice on numerical based on Norton theorem. Before starting, let's do quick revision. If you missed previous video, click on I button. In previous video, we had gone through Thevenin's theorem. We had discussed the procedure to reduce circuit and also practiced on numericals. So without wasting time, let's start with Norton's theorem. We will start with definition of Norton's theorem. Norton's theorem states that any linear complicated circuit can be converted in simple circuit with having one current source and one parallel resistance connected to it. Friends, here we need to focus on term linear circuits, as this theorem only works on linear circuits. As suggested in definition, single current source is known as Norton's current source and that single resistance is known as Norton's resistance. From this figure, concept of Norton's theorem can be understood nicely. Here, IN and RN are Norton's current and resistance respectively. But now, question is how to find this Norton's current and Norton's resistance. For that, let's take a simple circuit. Here I am considering node A and node B as a load path and 40 ohms resistance as a load resistance. Suppose I need to find current and voltage across this load resistance. For solving this circuit, plenty of method can be used, but here we are going to use Norton's theorem. Friends, by using this theorem, we will be able to convert this two-loop circuit into simple circuit with having only one equivalent current source and that equivalent resistance. Here, we will focus on procedure to find Norton's current and Norton's resistance. In order to find these two terms, we need to follow some steps. So let's start with calculation of Norton's current. Friends, in the first step, we will remove the load resistance and short that path. In following step, we need to determine the current through that short circuited path. In the circuit diagram, two loops can be seen with having different value of current I1 and I2. After solving this two loops equation, we are getting 2 ampere from short circuited path. Friends, here we have completed half portion of the sum. Now in this step, we are supposed to find Norton's resistance. It is defined as resistance between load terminals when voltage source is short circuited and current source is open circuited. Here, step 1 is remove the load resistance and redraw the circuit diagram. Friends, after removing the load resistance, our second step is to short all the voltage source and open all the current source. Then circuit will look like this. Now, in this step, we are supposed to calculate the equivalent resistance between 2 points. In our case, both are connected in parallel. Hence, Norton's resistance will become 6.67 ohm. After finding this, we got the value of Norton's current and Norton's resistance. Here, we can see that by using this method, how two-loop circuit is reduced to 2 ampere current source with 6.6 ohm Norton's resistance and 40 ohms load resistance. We wanted to find voltage and current through load resistance. Friends, for this combination, equivalent resistance is 5.72 ohm and hence voltage across load resistance is product of resistance and current, that is 11.44 volt. From this, we can find current through load, and that is 0.286 ampere. Let's make concept sharper with another example. Here, I am taking 3-loop circuit with having one current source and one voltage source. Now, we will find current and voltage across load resistance. We will start calculation with Norton's current. In the first step, we will sort the load resistance and redraw the circuit diagram. Now, our main task is to find current through short circuited path. Here, we are assuming current I1, I2 and I3 is flowing through loop 1, 2 and 3 respectively. Friends, here 30 ampere current is flowing in loop 1, so I1 will become 30 ampere. Same as current I3 is equal to Norton's current. I will surely suggest KVL in order to find current through short circuited path. So, in loop 1, 30 ampere current is flowing. Current equation for loop 2 and loop 3 is as mentioned. After solving both the equation, we will get 20 ampere from loop 2 and 30 ampere from loop 3. This 30 ampere will act as Norton's current. After finding Norton's current, our next task is to find Norton's resistance. Friends, procedure to find Norton's resistance is as same as Thevenin's resistance. Here, in the first step, we will remove the load resistance and redraw the circuit diagram. Now, in the second step, we are supposed to short all the voltage source and open all the current source. Hence, circuit will look like this. Our final step is to identify equivalent resistance between 2 points. Here, it can be seen that 10 ohm resistance and 5 ohm resistance is connected in series, and this whole combination is connected with 5 ohm resistance parallelly. So, equivalent resistance will become 3.75 ohms, and this is known as Norton's resistance. After this, we can see that how 3-loop circuit is reduced to simple circuit with 30 ampere current source and 3.75 ohm resistance. Friends, load resistor should be connected parallelly to Norton's resistor. And finally, using circuit analysis method, we can find current through load resistance, and that is 5 ampere. Voltage across load resistance could be found using Ohm's law. So, voltage drop across load resistance is 93.75 volt. After getting know about Norton's theorem, it can be summarized as it is one of the circuit solving technique by which we can find current through load resistance. Basically, in order to perform Norton's theorem, we should follow some steps. First step is remove load resistance. After that, find Rn by sorting voltage source and opening current source. Then after, find In using any circuit analysis technique. Finally, we will find load current. After attending this session, we learnt about Norton's theorem. We get to know about procedure how to solve circuit using this theorem. We also did a numerical practice based on Norton's theorem. In upcoming video, we will learn about superposition theorem. We will solve numerical based on superposition theorem. Stay tuned for upcoming videos. Kindly do like, share and subscribe this channel. Press the bell icon for regular updates. Thanks for watching.